The CableCURE process often includes the use of a temporary reservoir connected to the cable. This reservoir, known as a low-pressure feed tank, allows for the optimum amount of fluid to be fed to the cable's insulation. Without the feed tank, only the fluid volume that could coincidentally fit within the cable's conductor strands would be available to the cable's insulation. Instead, the low-pressure feed tank allows for the required amount of fluid to be utilized, ensuring long-term performance. This is important, as there are multiple factors that affect the optimum amount of fluid required to properly treat a cable's insulation. Some of these factors include the existing water content in the cable's insulation, the presence of a water halo, and the thickness and saturation level of the cable's two semiconductive shields. There is even a statistical component to the proper injection volume. You need many more water-reactive molecules, injection fluid, than water molecules to ensure contact and reaction with all the water molecules contained within the cable's insulation. Complicating the issue is that many of these factors, such as water content, are unknowable at the time of injection. All of these factors point to the need for more fluid. Additionally, as demonstrated by Dr. Wenchu's thesis titled Effect of Cable Restoration Fluid on Inhibiting Water Tree Insulation, any additional fluid not immediately employed in the cable's insulation forms a protective layer in the cable's exterior shields. Conversely, starving the injection process reduces or eliminates its effectiveness. In short, the intuitive result is that under variable cable and field conditions, more fluid is better. Consider the geometry of three common types of cable: 1/0 175 mil, 1/0 220 mil, and 1/0 345 mil. Each of these cable types has a different insulation volume. Therefore, each type requires a different volume of injection fluid for adequate treatment. However, the volume available between the conductor strands is the same in all three cases. It should be obvious that a single volume in the conductor strands simply can't offer ideal protection for three different insulation volumes. Without a feed tank, this one-size-fits-all approach to treatment is the approach used. It gets more complicated. For example, a 7-strand 1/0 cable can contain 69% less fluid than a 19-strand 1/0 cable, regardless of the thickness of its insulation. Finally, compaction rates differ dramatically. Therefore, it is not possible to rely on the interstitial space between the conductors as an appropriately sized reservoir for rejuvenation fluid. The UtilX CableCURE process does not assume that the tiny space between the conductor strands can be used as a reservoir. We view it as nothing more than a conduit for transferring fluid to the cable's insulation. It is indisputable that a low-pressure feed tank provides the flexibility necessary to supply the optimum fluid volume to each and every cable geometry. The feed tank provides another equally important function which may not be immediately obvious. The feed tank allows the exact measurement of the fluid that actually diffuses into the cable's insulation, not just the fluid that was put into the cable strands. Since the cable's interstitial spaces are already filled with injection fluid when the feed tank is installed, no fluid can leave the feed tank until the existing fluid in the cable moves into the cable's insulation. This provides measurable accountability that should be required of all engineered systems. Only the low-pressure feed tank provides unmatched flexibility to accommodate all cable geometries and insulation volumes. Only the low-pressure feed tank provides engineered process measurement and control. Only the low-pressure feed tank process has been employed for more than 20 years for the rejuvenation of more than 120 million feet of cable. UtilX, the global leader in cable life extension technology.